Hi, my name is Alara Güvenli, and I'm a third-year undergraduate student studying behavioral and cognitive neuroscience, and I do research in the labs of Dr. Bison and Dr. Setlow. My project studied the effects of cannabis smoke exposure on working memory performance in aged rats. So cannabis is the most widely used drug in the United States, and individuals over the age of 65 are becoming the fastest growing demographic of users. Aging is associated with impairments in cognitive functions mediated by the prefrontal cortex and hippocampus, so it'll be vital to understand how cannabis affects these regions as this demographic of users grows in size in the coming years. Prior studies have researched cannabis via injection, however, it's most commonly inhaled via smoking, so the goal of our project was to study the effects of cannabis smoke exposure on tasks mediated by the prefrontal cortex and the hippocampus. So we used male brown Norway rats, young, which were 6 months old, and aged, which were 24 months old, on the prefrontal cortex dependent delayed response task, in which the sample phase had a square lit up, and then there would be a delay phase, a variable delay from 0 to 24 seconds, and then in the choice phase, 2 squares would light up and the rat would have to select the one that was originally lit. In the trial unique to non-match location tunnel task, which is the hippocampal dependent task, there would be a sample phase where a square would light up, and then in the choice phase, 2 squares would light up, which would be a variable distance apart from each other, and the rat would have to choose the one that was originally not lit. So prior to any cannabis smoke exposure, aged rats showed impaired performance on both of these tasks. For the cannabis smoke exposure, rats were placed in smoke chambers in which cannabis cigarettes were consecutively burned via an apparatus, either 0, 3, 5, or 10 cigarettes. So the results. On the prefrontal cortex dependent delayed response task, aged rats showed an increase in accuracy, while young rats decreased in accuracy, and aged rats showed decreased number of trials. On the tunnel task, exposure to cannabis smoke did not have an effect on accuracy in either group. However, it once again decreased the number of trials in aged rats. The pharmacokinetics show that aged rats show a higher time concentration profile than the younger rats, and they also reached a greater maximum concentration in their plasma. So in conclusion, cannabis smoke exposure can increase prefrontal cortex dependent cognition tasks in aged rats and does not have an effect on hippocampal dependent regions. Thank you.